Hi guys, my name's Colby Hodnett. Today we're going to be talking about machine learning with neural networks. By the end of this video, I really hope you have a good graphical understanding of how neural nets work, as well as a basic understanding of coding one and the math behind all of it. So let's look at where these are used. Now, Wall Street uses these every day to predict stock prices. Businesses are using them now to predict the strength of future sales trends and revenue income. Facebook is using something called a convoluted neural net, which is a different type that we're going to talk about today, to recognize your face and pictures that you upload, as well as different neural nets to filter your newsfeed. IT fields are using these models for data analytics, sales projections, somewhat in security protocols, and so many other things. So let's look at this graphical representation of how a neural net works. Here's our input data, x1 and x2, and they hold a value. And before we assign them to these input neurons, we're going to normalize them, which means to assign them a value between 0 and 1. The reason we do that is because of something called a sigmoid activation function, and we're going to talk about that later. Now, you can see this input neuron has lines coming out of it, as well as does every other neuron. But these lines are called synapses, and they hold a weighted value. Now, the reason they hold a weighted value is because look at this neuron in this first hidden layer. And guys, this is our input layer, this is hidden layer 1, this is hidden layer 2, and this is our output layer. So if you look at this neuron in this first hidden layer, it is affected by this neuron in the input layer and this neuron in the input layer. And it is affected differently by each neuron due to the weights of those synapses. So, and every synapse holds a weighted value. So when we train a neural net, we take the input data value, x1 and x2, and we normalize them, sticking them into the input neurons, and then we run them through, and then we get an output. And that output is called y hat. And we compare y hat to y, which is what it's supposed to be, and we see how far it is off. And then using something called a cause gradient function, which we're not going to talk about in this video, we determine which direction we need to go and how far. So then in a process called backpropagation, it comes through and it adjusts these weights of all the synapses as well as the activation values in all these neurons in the different layers throughout the net. And then once it gets all the way back to this input layer, it takes the data again, feeds it through, and then we get a new value. And then we kind of do this thousands and thousands of times until we get really good at predicting y and what it's supposed to be. Quick look at the math now, guys. This isn't all of it, but it's some. So here's a layer of neurons and their corresponding activation values. What we're trying to do is assign a new activation value of a new neuron in this next layer of neurons. So we take the activation value of all these neurons and we stick them inside of this matrix. We take the weights of the synapses that affect this neuron and we stick them in this row of this matrix. If we had another neuron, say down here, we would take the weights that affect it and stick them in this row. Then we take the dot product of these two matrices and then we stick them in a sigmoid activation function, which is right here. Guys, the equation is represented by this equation right here typically. And the output looks like this, where it's a matrix of all the activation values of all the neurons inside this layer right here. You can see, since we only, in this scenario, we only have one neuron, so that's what's shown here. So let's look at the code that I did for the demonstration. All right, guys, we're writing in Python right now. It's really cool code. What we're trying to do is predict the grade of test number 5 based off previous tests. So for the input, we have this first column right here, which is representative of how much you studied for the test. And then this column right here, which is representative of how much you got sleep you got the night before the test. So, and the output data as well is the grades of each test. So for test 1, you got a 0 because you didn't study and you didn't sleep the night before. So when we predict test 5, the grade for it, this is the input data, which in this scenario, we're going to say that you didn't study very well and that you didn't get much sleep, so about half and half. So then we run it through, we assign random values for all the weights to begin with, and then we run it through 60,000 iterations. Guys, here's the equations we were talking about, where we take the dot product of the activation values and the weights of each synapse. Backpropagation portion where we're changing the synapse. I've already compiled it. You can see the value got really good at predicting this value up here, what it was supposed to, and then it predicted a 91 for the test of grade 5, which is really cool. All right, guys, so we're back in the PowerPoint. I just want to sum up right quick. Neural nets, they take an input and they predict an output based off previously trained data. And they're only as good as how much you train it and the data that you feed it. Guys, they're everywhere. We see them all the time, from Siri to toll roads, and they use neural nets to read your license plate and the pictures. Guys, they're awesome. They're really cool. Really hope you enjoyed this presentation. Really hope you have a somewhat understanding of how they work now. If you have any questions, leave a comment, send me an email, however you want to do it. Hope to hear from you. Thanks for watching.